Hello everyone, this is Hitesh, and on the behalf of my group, which is a group number 4, I will be explaining the graph database practical using Neo4j. So let us have a look at the outlines of our presentation. So first I will be introducing about the Neo4j, then moving on to the features of the Neo4j, which make him specialized and different from other graph database management system. Then I will be telling about how to import database into the Neo4j with the help of the Cypher query. Then moving on to the how we can use and implement Cypher queries to get meaningful data from the database. And at last, I will be discussing some application of Neo4j. So let us first introduce the Neo4j. So Neo4j is highly popular and powerful graph database management system. It is designed to efficiently store, manage, and query highly connected and complex data. Unlike traditional relational databases that organize data into table and rows, Neo4j organizes data in node and relationships, which are represented as a graph. If we talk about Neo4j, nodes represent entities or objects, relationships represent connections or association between them. Each node can have properties that define its attribute, and relationship can have properties to describe their characteristics. The relationships are always directed and can have a specific type. And if we talk about the example that we have shown in this slide, so this example is basically represent a scenario of sending an email to one person and copying the same mail to a third person in the CC field. CC field basically means carbon copy. If we talk about this example, there are three entities: the sender, the primary recipient, and the third person in the CC field. Each entity will represent as a node in the graph, and the relationship between them will be represented as directed relationship. This graph structure allows for efficient traversal and query of relationships. For example, you can easily find mails sent by a particular sender, retrieve the primary recipient of those emails, and identify the third party recipient who were copied on the mails. By utilizing the query capabilities of Neo4j Cypher language, you can perform various operations on this graph, such as retrieving all emails sent by a specific sender, finding the CC recipient of a particular email, or identifying email that was sent to a specific recipient. This, this is a simplified example, but you can extend and enhance it based on your specific requirement, such as adding additional properties to nodes or relationships to capture more details about the email or the individual involved. If we talk about more about the Cypher query language, so Cypher query language is basically designed for working with graph data. Cypher allows you to create, update, retrieve data from graph database using a concise and expressive syntax. It supports pattern matching, filtering, aggregation, and other operations to explore and analyze the graph data. So moving on to the features of the Neo4j, there are many features of Neo4j. Let us talk about each feature one by one. The first one is high performance. Neo4j is optimized for handling large-scale graph data and complex queries. It leverages graph-specific algorithms and indexing technique to deliver fast and efficient operations. Second feature is scalability. Neo4j can scale horizontally by distributing data across multiple machines in a cluster. This allows it to handle growing datasets and high query loads. Moving on to the next feature, that is ACID compliance. Neo4j ensures data consistency and reliability by supporting ACID, that is atomicity, consistency, isolation, and durability transaction. Moving on to the next feature, which is flexibility. Neo4j provides a flexible data model that can adapt to changing requirements. You can easily add or modify nodes relationship, and they have properties without affecting the overall structure of the graph. The next one is rich query language. Cipher, the query language of Neo4j, offers a declarative and intuitive way to express graph pattern and operations. It allows you to express complex graph queries concisely. Last feature is integration, that is, Neo4j integrate with various programming languages and frameworks, making it easier to incorporate graph data into your application. It also provides connectors and APIs for seamless integration with other systems and tools. So let us first understand how we can import database into Neo4j, and with the help of the Cypher queries, we would be able to get meaningful information from them. So first you need to install Neo4j into system. After that, what you need to do is that you need to create a new database with any name you can create. I have created with big underscore data underscore project, and apart from that you have to provide password also, and then you have an option of connecting to the server, and as you can see I have already connected with my server. So after that what you need to do is that under the app section you have to click on the Neo4j tab. As you click on the Neo4j tab, you will be directing to a new page like this. So here you can see there are types of databases you can see. So let us see, we need to first import our database. So I have written the query for importing database. So I have taken an NBA database, which is basically means National Basketball Association data. So as you can see, we would be having three kind of data like team, player, or coaches, and according to them, uh, each player can have an age, height, or weight, and each player will be playing under a certain team, under a certain coach. So for that, I have created relationship amongst the Cypher query and the data. So once you once you have written this query, you can directly create a database into it. And if you want to see whether you are able to create database or not, you just need to write match underscore return and then you will be able to see that whether your database is created or not. So as you can see, I have created my dataset, and this is my database. So where team is representing by yellow color, player is representing by blue, and coach is represented by 7. So as Cypher query is basically similar as SQL query. So in SQL we were having select, and here we would be having match and return. So let us understand how we can extract data from it one by one by writing Cypher queries. So what this match and return is doing is that it is basically extracting the data and then returning it. So let us first extract some player name. So as you can see player, and we just need to write the return statement instead of and. So if you will be writing like that, you will be able to get all the players in your database. So it is basically representing along with the teams, like as you can see. Yeah, so like Joel Embiid and Tobias Harris are in the same team, and Russell and Throny or LeBron are in the same team. So it is representing in a team wise. If you want to see into a table wise, you can see here also. But as we are doing for the graph database, so we need to see here only. For similarly, you can write for the coaches if you want to extract all the coaches that are available in in our database. So we are writing it like that. And okay, so we have not written here the return statement. So return coach. So now this will be returning us all the coaches. We have done some mistake. Okay, yeah. As you have to be specific about the case sensitive, because this language is case sensitive. So yeah, so as you can see, we would be having these as the coaches, like Doc Rivers, Taylor Jenkins. These are all the available coaches. There are 7 number of coaches, and these, the count of it is 7 also. If you want to extract the teams, so you need to write in a similar manner like team, and then after that you need to return team. So as you can see, there are 6 teams like Brooklyn Nets, Los Angeles Lakers. So these are all the 6 teams that are available in our database. Now we need to extract all the players' names along with their height or the weight. Then we need to use as an alias. So player colon player, then you can write return player name, as it is the attribute of the player. As we are writing, like if you click on this any player name, then all the attribute, all the properties of that node will be representing. So it is having a name as a property, so we are writing player dot name as name, or player dot height as height. So we will be getting name as player name, and player's height as height. After that, if you want to return for any specific player, then we can write that also. Like if you want to write for any particular player, like LeBron, return. So we would be having a keyword named as order by. So we would, by using this query, we would be able to get the players according to their height in the descending order. So as you can see in the table, you can easily see that we will be getting the descending order by their height. So it is 2.21, 2.13, then 2.11, and so on. And if you want to get the same result by using ascending in ascending order, then you can just simply type ASC. So you will get the result in the ascending order. As you can see, 2.01, 2.01, 2.03, 2.06. So moving on to when you want to get the multiple data at the same time, so what you need to do is to just type two table name at the same time. So you can type player comma coach colon coach, and after that you just need to type where condition, where player dot height is greater than equal to 2, and just return player and coach. This will provide you the player and the coach. So as you can see, coach is represented by the yellow node and player is represented by the blue node. So each coach is basically what it represents is that a coach under which two players are playing and whether they are the teammates or not. So it helps us a lot in visualizing under which coach which player is playing. And if you want to get the team as well, so you can just simply type along with that team also, just type team colon team, and here you can also type team. So along with that you can get the team also, as you can see. So this is the team. As you can see, it is quite dense, so just limit it by 2 or 3. So I am limiting it by 2, so you will be getting only the 2. So as you can see, 2 teams are there and under there is one coach and the player is there. So moving on to the other queries that will help us to get the important data. So let us understand now the query for relationships. So for that you just need to make the relationship, so it is quite important. So let us first understand how we can write the query for it. So you basically need to type the minus symbol with square bracket and again minus symbol with the arrow key, and then you need to type the relationship for with whom you want to form the relationship, and after that you need to type the where condition, where team dot name is equal to, let's say, Los Angeles Lakers, and you just need to simply return. So return player, and in this relationship you need to basically tells what is this relationship for. For that you need to write the within the square bracket relationship. So these are the relationships. So currently I am using the relationship for plays for team. So yeah, so there was an error where it should be team only. So as you can, yeah, so this looks fine. So it is the player, and if you write the team also, then you will get the corresponding team for each player playing for which team. So these are the three players which are playing for the Los Angeles Lakers, and they are the teammates. So as you can see, this is the use of the benefit of relationship, and along with that relationship are also having properties. So if you want to perform more operations on your relationship, then you can simply perform, like, you can perform many operations such as uh, like the filtering on the contract salary for the players. Along with that you can perform other operations like which are having the highest salary among the current players for each team. So let us see some queries one by one. So let us first extract the player which are playing for a particular team whose salary is greater than 33.5 million. So for that you just need to change the relationship from plays for, then we would be using the contract relationship for them, and after that you just need to, in where clause, you just need to perform the contract dot salary greater than equal to 3.5 million, and then you just need to return the player. There is some error. Let us see. Here it is. Player colon contract. Place for is the relationship. Then with the arrow, you can just where contract dot salary. That's fine. Okay, here we miss the return statement. Return player. So these are the players. As you can click on this. So these are the players which are having the salary more than 3.5 millions. So that was all about the our practical that we have done using Neo4j, and as you can learn from more into the Neo4j by using by learning the cipher queries. So that was all about the implementation that we have done. So let us see the applications of Neo4j one by one. The first one is social network. Neo4j can represent friend and follower relationship between users. Each user can be represented as a node, and friend with or follows relationship can be established between them. This allows for efficient retrieval of a user's friend or follower or mutual connections. Another application of Neo4j can be in the recommendation system. Neo4j graph-based querying capabilities, making it suitable for building recommendation system in social network. By analyzing the connections and activities of users, such as their interests, likes, interactions, Neo4j can provide personalized recommendations for users to discover new friends, groups, events, or content. The last application is fraud detection. Neo4j can model various entities involved in fraudulent activities such as individuals, organizations, accounts, transactions, and their relationships. By representing these entities as nodes and their interactions as relationships, Neo4j can detect patterns of collusions, identify suspicious activities, and uncover hidden connections that indicate fraudulent behavior. So that was all about our graph database practical. Thank you so much.